NEC 110.26 establishes the minimum clearances for electrical equipment. This is to prevent accidental contact and ensure safe access for maintenance and troubleshooting. It applies to all electrical installations, including those in industrial machinery. While Article 670 of the NEC provides specific requirements for industrial machinery, it does not exempt the equipment from other applicable NEC articles, including Article 110. Therefore, the control gear within the industrial machinery must still comply with the clearance requirements of 110.26. NFPA 79, which addresses electrical safety in industrial machinery, does not specify clearances directly. It relies on the NEC for fundamental electrical safety requirements, including clearance specifications. In the scenario described, the control gear is located within the equipment and may be accessible while it is live. Therefore, the clearances within the equipment must be assessed to ensure compliance with NEC 110.26. Failure to provide adequate clearances could result in electrical hazards. While the manufacturer is responsible for designing the equipment to meet applicable codes, it is the responsibility of the end users to ensure that the equipment is installed in accordance with local electrical codes, including NEC 110.26. Therefore, the control gear within the industrial machinery must comply with the clearance requirements of NEC 110.26. While NFPA 79 does not specify clearances, it does not override the NEC requirements. Therefore, both the manufacturer and the end users have a responsibility to ensure that the equipment is designed and installed to meet the necessary safety standards. To elaborate further on NEC 110.26, it is crucial to understand its scope and how it applies to various electrical installations. The primary goal of this section is to provide sufficient working space around electrical equipment to permit ready and safe operation and maintenance of such equipment. This working space includes considerations for height, width, and depth, all of which must meet specific requirements based on the voltage and configuration of the equipment. Now let's delve deeper into the specifics of NEC 110.26. Firstly, the section addresses the need for sufficient access and working space around electrical equipment. This space is not just for routine operations but also for maintenance, repairs, and potential emergency situations. The code specifies minimum distances based on voltage levels and the presence of exposed live parts on one or both sides of the working space. For instance, in situations involving 208-volt systems, the required working clearances depend on the conditions outlined in Table 110.26a. Condition 1 is where there are exposed live parts on one side and no live or grounded parts on the other side of the working space, or where there are exposed live parts on one side and insulated parts on the other side. Condition 2 is where there are exposed live parts on one side and grounded parts on the other side. Condition 3 is where there are exposed live parts on both sides of the working space. The depth of the working space varies depending on these conditions, with greater depths required when live parts are present on both sides or when grounded parts are present opposite the live parts. Secondly, the height of the working space is also critical. NEC 110.26A3 requires a minimum headroom clearance of 6.5 feet of the height of the equipment, whichever is greater. This ensures that personnel can stand upright and move freely while working on the equipment. Thirdly, the width of the working space should be at least 30 inches wide or the width of the equipment, whichever is greater, allowing for adequate lateral movement and preventing accidental contact with adjacent equipment or structures. Now consider the specific context of industrial machinery. Article 670 of the NEC provides additional guidelines tailored to the unique characteristics of this type of equipment. However, it's important to emphasize that Article 670 does not supersede the general requirements of Article 110. Instead, it supplements them with provisions specific to industrial machinery. This means that even if the equipment meets the requirements of Article 670, it must also comply with the applicable sections of Article 110, including 110.26. In the case of control gear located inside the industrial machinery, the question arises whether the clearances specified in NEC 110.26 must be met within the equipment itself. The answer is generally yes. The intent of the code is to ensure that personnel have safe access to electrical equipment for troubleshooting and maintenance, regardless of whether the equipment is installed in a dedicated electrical room or integrated into a larger piece of machinery. Therefore, if the control gear is accessible while energized, the clearances within the equipment must comply with NEC 110.26. However, there may be some exceptions or alternative approaches that can be considered. One approach is to energize the equipment completely before performing any work on the control gear. In this case, the clearance requirements may be relaxed, as the risk of electrical shock is minimized. However, this approach may not always be practical, especially when troubleshooting live circuits is necessary. Another approach is to use barriers or other physical safeguards to prevent accidental contact with live parts. For example, insulated covers or partitions can be installed to isolate the control gear from other components within the equipment. This can reduce the required working space, as the risk of accidental contact is reduced. It's also important to consider the role of NFPA 79, the electrical standard for industrial machinery. While NFPA 79 provides comprehensive guidelines for the electrical design and construction of industrial machinery, it does not specify the same detailed clearance requirements as NEC 110.26. Instead, NFPA 79 relies on the NEC for these fundamental safety requirements. This means that manufacturers of industrial machinery must comply with both NFPA 79 and the NEC, ensuring that their equipment meets all applicable safety standards. In practical terms, this means that manufacturers must carefully consider the layout and accessibility of control gear within their equipment. They must ensure that sufficient working space is provided to allow for safe troubleshooting and maintenance, taking into account the voltage levels and potential hazards involved. They may also need to implement additional safeguards, such as barriers or interlocks, to further reduce the risk of electrical shock. From the perspective of the end user, it is crucial to verify that the industrial machinery is installed in accordance with all applicable codes and standards, including the NEC. This includes ensuring that the equipment is properly grounded, that overcurrent protection is provided, and that sufficient working space is maintained around the equipment. End users should also train their personnel on the safe operation and maintenance of the equipment, emphasizing the importance of following lockout-tagout procedures and using appropriate personal protective equipment. In conclusion, NEC 110.26 is a critical safety standard that applies to all electrical installations, including those in industrial machinery. While Article 670 of the NEC and NFPA 79 provide additional guidance specific to industrial machinery, they do not supersede the general requirements of Article 110. Therefore, manufacturers and end users must work together to ensure that industrial machinery is designed, installed, and maintained in a manner that complies with all applicable codes and standards, providing a safe working environment for personnel. Let's dive into some specific examples to illustrate how these concepts apply in real-world scenarios. Firstly, consider a large industrial milling machine used to process metal components. This machine contains various electrical control panels housing programmable logic controllers, motor drives, and power distribution blocks. These components operate at 208 volts and are essential for controlling the machine's movements and function. According to NEC 110.26, sufficient working space must be provided in front of these control panels to allow electricians to safely troubleshoot and maintain the equipment. This working space must meet the minimum depth, width, and height requirements specified in the code, taking into account the presence of exposed live parts and grounded surfaces. If the control panels are located in a confined space within the machine, it may be necessary to redesign the layout to provide adequate clearance. This could involve moving the panels to a more accessible location, using smaller components, or implementing barriers to isolate live parts. Secondly, consider a robotic welding cell used in an automotive manufacturing plant. This cell consists of several robots, each with its own dedicated control cabinet. These cabinets contain the robot's control system, power supplies, and safety circuits. The control cabinets operate at various voltage levels, including 208 volts, and are often interconnected with communication cables and power wiring. To comply with NEC 110.26, the control cabinets must be arranged in a manner that allows for safe access and working space. This may involve spacing the cabinets apart, providing walkways or platforms, and ensuring that the doors of the cabinets can be fully opened without obstruction. In addition, the wiring and cabling within the cabinets must be neatly organized and properly labeled to facilitate troubleshooting and maintenance. Thirdly, consider a packaging machine used in a food processing plant. This machine includes numerous sensors, actuators, and control devices that are essential for automating the packaging process. The control system for the machine is housed in a central control panel, which contains a variety of electrical components, including circuit breakers, relays, and terminal blocks. Because the machine is located in a food processing environment, it is subject to strict hygiene requirements. This means that the control panel must be designed to be easily cleaned and sanitized. It must also be protected from moisture, dust, and other contaminants. To comply with NEC 110.26, the control panel must be installed in a location that provides adequate working space and allows for easy access for cleaning and maintenance. The panel must also be properly sealed to prevent the ingress of contaminants. Furthermore, the wiring and cabling within the panel must be suitable for use in a food processing environment with materials that are resistant to corrosion and microbial growth. In each of these examples, the application of NEC 110.26 requires a careful assessment of the specific equipment, the operating environment, and the potential hazards involved. Manufacturers and end users must work together to ensure that the equipment is designed, installed, and maintained in a manner that complies with all applicable codes and standards, providing a safe working environment for personnel. Let's explore some specific considerations for troubleshooting live control gear within industrial machinery. Firstly, it is essential to emphasize the importance of qualified personnel. Troubleshooting live electrical equipment should only be performed by individuals who are properly trained and qualified to work on such equipment. These individuals should have a thorough understanding of electrical safety procedures, including lockout-tagout, personal protective equipment, and arc flash hazards. Secondly, it is crucial to conduct a thorough risk assessment before beginning any troubleshooting work. This assessment should identify potential hazards such as exposed live parts, arc flash risks, and confined spaces. The assessment should also determine the appropriate personal protective equipment that is required, such as safety glasses, insulated gloves, and arc-rated clothing. Thirdly, it is important to use appropriate test equipment and tools. Multimeters, oscilloscopes, and other test equipment should be properly calibrated and in good working order. Tools should be insulated and designed for use on live electrical circuits. Fourthly, it is essential to maintain a safe working distance from live parts. Whenever possible, use remote testing methods to avoid direct contact with energized circuits. If direct contact is necessary, use insulated tools and wear appropriate personal protective equipment. Fifthly, it is crucial to be aware of potential arc flash hazards. An arc flash is a dangerous electrical explosion that can occur when a short circuit or other electrical fault occurs in energized equipment. Arc flashes can cause severe burns, blindness, and even death. To mitigate arc flash hazards, it is important to de-energize the equipment whenever possible. If de-energizing is not possible, use arc-rated clothing and face shields to protect against potential arc flashes. Sixthly, it is important to follow lockout-tagout procedures. Lockout-tagout is a safety procedure that is used to prevent accidental energization of equipment during maintenance or repair. This involves disconnecting the equipment from its power source and locking out the disconnect switch with a padlock. A tag is then attached to the disconnect switch, indicating that the equipment is being worked on and should not be energized. Seventhly, it is crucial to be aware of confined space hazards. Some industrial machinery may contain confined spaces, such as control cabinets or enclosures, that pose additional hazards. These hazards can include lack of ventilation, exposure to toxic gases, and difficulty in rescue. Before entering a confined space, it is important to follow confined space entry procedures, including testing the atmosphere, providing ventilation, and having a standby person present. Finally, it is essential to document all troubleshooting work. This includes recording the steps taken, the results obtained, and any corrective actions performed. This documentation can be valuable for future troubleshooting and can also help to identify potential problems with the equipment. In summary, troubleshooting live control gear within industrial machinery requires a combination of technical knowledge, safety awareness, and adherence to established procedures. By following these guidelines, it is possible to safely troubleshoot and maintain electrical equipment while minimizing the risk of electrical shock, arc flash, and other hazards.